work just so I could finish that. I was like, sure, we can have even more time. Okay, so first 2xy, negative 2xy. So remember, when you have the letters right next to each other, it means multiplication. So negative 2 times x is 4 times y is 4. And negative 2 times 4 is negative 8 times 4 is negative 32. Okay, and square root of 144. Okay, so let's just review. What is the square root asking? It's saying what number times itself is 144. Do you guys know what number times itself? Yes, 12. Beautiful. So I make this little factor tree to show that it's 12 times 12. Square root of 144 is 12. Those are my favorite two warm-ups of all time, I think. Okay, we are going to use a page in this packet, but not right away. So find the resource page for today. It's got a bunch of function machines on it. And then just scooch this guy off to the side. And grab your notebook, graph paper, whatever you're. Okay, guys, let's do 33, and then I'll move the notebook down so you can see all of 34 better to set that up. Number 33 is a is a table. We are going to find the growth. We're going to find the start, and then we're going to find the rule. This is probably review. Okay, first, how much is it going up each time? Yes, 3. Beautiful. Okay, so I like to make my little Amazon arrows under here. You guys know what I mean by that, right? Okay. And hopefully it's not indicating how much shopping I do from there. So my growth is 3. And my start, I want to make sure everyone knows that the start for us is going to be figure 0. So whatever is at 0. So if it's linear, which means that if you graph these dots and it makes a line, or if it goes up by the same amount each time, the rule is y equals growth times x plus figure 0. You guys had one of these on your work from last night. I think the first one. Okay, so in this case, it would be y equals, the growth is 3 each time, times x. I don't really write the times, I just put the x right there. And then plus figure 0, there's -1, so I'm going to put -1. Okay, so now I'm going to give you time to draw this. There is a function machine on your quiz today. Okay, everybody. So let's start with the function machines. I have three different types here. These two are actually the same. This one is backward. So when I say forward function machine, that means I give you the input and you're going to plug it in for X. So this one would be 3 times 3 minus 1. So I took my 3 and I plugged it in for X. And when they're right next to each other, that means multiplication. 9 minus 1, which is 8. Does anyone have any questions about that so far? Okay, now we have something kind of new. This was on your digital escape, and it's called function notation. Okay, I have a weird question. How many of you were allowed to watch SpongeBob? Anyone allowed to watch SpongeBob? Oh, thank goodness. Then most of you will understand most of my references. I'm a very big SpongeBob fan. And there is this one episode where Patrick was, I think SpongeBob was going to have tea with Sandy in the tree dome. And he said, Patrick said that he has to talk fancy. And he said, when in doubt, repeat out, right? Okay. Function notation is just fancy notation. It's just writing it fancy. It's no different from this. It's just that you have f of x instead of y. F of x, and when you see this, you say f of x. And when you see that, it's the same thing as y. And if you hate it, you can actually put a y there every time all the way through calculus. So f of x and y are the same thing. Y is just your normal notation. F of x is fancy. Why do we use f of x? Because in the x spot, you'll get to the end of your problem and you'll be able to tell what the input and the output were. At the end of this problem, you just say the output's 8. But at the end of this problem, you'll be able to see the input was 3 and the output was 8. So you'll have all the information at the end. That's the reason that we use function notation. But the math is exactly the same. So we take the 3, and I'm going to put it here and here. I'm going to put it everywhere there is an X. I'm actually going to take this guy and make him 3. Three times 3 minus 1. Three times 3 is 9 minus 1. Final answer still 8. There's no difference between those two things. It's just regular notation and fancy notation. Do you guys see what I mean by you can see the input and the output at the end? That's the advantage of function notation. So this is just a name. This is like Frank at 3. That's being like just his name, whichever one is F. Remember the digital escape, how some of them were like F and G and H, and you had to like pick the right one? So those are just their names. Okay, now the last one is actually different. Backward function machine gives you the output and you have to tell the input. I bet you guys know what the input is from these two. Output is 8, input is 3. Beautiful. Okay, but how do I get that working backwards? Do you see how both of these things say f of x? That means I'm going to take the 8 and put it on this side of the equals. So I take my output and I put it on this side of the equals. And now I have an equation. Add 1 to both sides. And there's my input of 3. So there's your forward with function notation, and backward. And we're going to practice this again in number 36. Number 35 is this table. Does anybody know what's happening in this table? Can anyone tell me what's going on? The biggest clue is this right here, I think, 49 and 7. Yes.
The number for x is 3.
Yes. Okay. So square root of 9 is 3. Square root of 100 is 10. Square root of 4 is 2. Ooh, but now we need to go backwards. Square root of what is 4? 16. Great. What about 0? What's the square root of 0? 0. Okay, and this guy, square root of 20. About 4.5. We're going to put little squiggle guys. We're going to say approximately 4.5. Okay, so if I were to write the machine for this, I would say f of x, so y, that's the bottom row, is the square root of the top row. The bottom row is the square root of the top row. Okay, you're done with your notebook. You can switch that over and then grab that page we were talking about from your packet. And the first thing I want you guys to do is to look at these, take 20 seconds and put an F next to the problem if it's a forward function machine, and put a B next to it if it's a backward function machine. So take a look at all of these. There's 9 of them. Identify which one are the forwards and which one are the backwards. Oh man, is there a pattern happening here? Nope. BFF. How do we do? Okay. Let's take a look at A. A says x is -3. So I'm going to say f of -3. I'm going to plug -3 in here and here equals -2 times -3 plus 4. -2 times -3 is 6 plus 4 is 10. Okay, go down to D. I'm going to plug x in here and here. F of -2 equals the square root of -2 plus 1. Yes. Yes. Beautiful. Not possible? Which is why I picked that one to do together. Okay, take a look at the next column, B, E, and H. Do you guys think you could do those on your own? Do you know what to do? Okay, now let's scooch over to the last column, C and F. These ones are backward ones. They're going to take us a little bit more thought. Okay, B. Backward function machine. So I'm going to take the 125 and put it on the other side of the equals. And what is this problem saying? It's what number times itself is 125. 5. Yep. Okay. This is how we show it in algebra. So we say, how do you undo a cubed? Cube root. Okay, we have another kind of hard backwards one here. So backward machine, that means I'm going to put 99 on the other side of the equals. Okay, and this one is spicy. I'm going to tell you guys I would circle this one. This is going to come back to you later, and it's really spicy, so we need to be really careful. First, I'm going to add 1 to both sides. Okay, what number times itself is 100? Yes. And what other number times itself is 100? -10. This is the spicy bit here. This actually has 2 correct answers. What we do is we square root both sides. And we put a plus or minus in front. Okay, if you're really, really concerned about that, which I don't blame you if you are, let's see if Mrs. Talbot is making up crazy stuff. What is 10 squared minus what? 99. Okay. What is -10 squared minus 1? 99. Oh no, they both work. Okay, so what you have to do is you have to remember when you square root both sides, there's 2 possible answers. Okay, let's go over to G and then we're going to do 37, and then I'll let you finish these other ones. Okay, backward function machine. That means I'm going to put the -3 on the other side of the equals. Absolute value of what number is -3? Also not possible. Okay, so take a look at B, E, H, and I. Do you guys think you know how to do those 4? They're all forward ones, plugging in for X. Okay, I'm going to give you some time to work on those, but we're going to do 37 together real quick. Because 37 is also spicy. And I'm going to zoom into this graph pretty far. Okay, A. When the input is 1, what is the output of the function? That is, find the value of g of 1. Okay, what that means is locate the coordinate where x is 1. So go to the origin, which is right here. And then can you guys see that 1 is here? So make a little coordinate where x is 1. What is that coordinate? 1, 1. That coordinate is 1, 1. So that means g of 1 is 1. There's your x, there's your y. Okay, B. Likewise, what are g of negative 1 and g of 0? Okay, so g of negative 1 is right here. So I went to the origin and I went back 1 and then made my coordinate on the curve. What coordinate is that? Negative 1, negative 2. Okay, perfect. Okay, so what we say is g of negative 1 is negative 2. There's your x, there's your y. Okay, let's do 0. 0 is right here. That coordinate is 0, negative 1. G of 0 is negative 1. Okay, last part, C. What is the input of this function when the output is negative 2.5? Okay, so what this is saying is, what is x when y is negative 2.5? It's going to be really hard to tell. Zoom in really far. Okay, so negative 1, negative 2, negative 2.5 is like right there. Right here. You guys think it's right there? Okay, so that would be negative 2, negative 2.5. So g of negative 2 is negative 2.5 x, y. Is there any way that maybe in the future you could make that graph bigger? I suppose that would probably be a good idea. Graph is too tiny. Okay, so you guys have 7 minutes to do B, E, H, and I. And then also take a look at the homework. Do you guys know what the homework is? Let's take a look. 1-38 to 1-42. Do you know where to find those problems? Yeah, okay. So you're going to go to your Clever, which is not this thing that's showing right now. And you're going to log in as a student, but for me, I'm going to log in as a teacher. And you're going to find this one right here that says CPM with the little bridge on it. And when you click that, it's going to ask you to agree to something. And then you click eBooks. And you guys should have this blue one right here that says integrated 1. I click on that. And then this is a fact. Even if you're a CPM master, you might not know this. If you hover your arrow over top of these, it tells you what problem numbers are in each thing. So ours are 38 to 42, which is here in 1-1.2.1. And then you scroll down, and all of our homework's going to be in the review and preview section. So there's 38, 39, 40, 41, 42. Okay, and you're going to do that in your notebook right after where we did 33 through 35. Does that make sense? Okay, now we need to talk about one more thing. This homework is not due on Thursday. You guys all realize you do not have me tomorrow, correct?